Let's look at OpenStack's College Physics, Chapter 16, Problem 32. At what rate will a pendulum clock run on the moon, where the acceleration due to gravity is 1.63 meters per second squared, if it keeps time accurately on Earth? That is, find the time in hours it takes the clock's hour hand to make one revolution on the moon. So let's write down the things that we know and don't know. So we're told that the acceleration due to gravity on the moon, G, call it G sub m, is 1.63 meters per second squared. We know that acceleration of gravity on the Earth is 9.8 meters per second squared. And we know that on the Earth, the hour hand makes one revolution in 1 hour. So we know the period of the hour hand on Earth. We're looking for the period of the hour hand on the moon. So here we have the diagram. It's a clock and it has a pendulum attached to it, a simple pendulum. So if I look at the equation sheet, I get to the bottom equation here and know that the angular frequency of the pendulum is square root of G over L. Now, we're given period, not angular frequency, but we know that there is a relationship between period and angular frequency. We also know that the length of the pendulum is L, and we have L in the equation over here. So let's combine all these equations and see what we can get. So I have omega is 2 pi over the period, which means that period is 2 pi divided by omega. Then we know that omega is square root of G over L, which means that the period will be 2 pi square root of L over G. There we go. So that is true both on the moon and on the Earth. So I'm going to write T on Earth is 2 pi square root L over G Earth, and T on the moon is 2 pi square root L over G moon. Dividing these two equations one by the other, I end up with period on Earth divided by period on the moon. The 2 pi's cancel out, the length of the pendulum L cancels out, and we're left with square root G on the moon divided by G on Earth. So we're looking for the period on the moon, and that's going to be period on the Earth, square root of G on the Earth divided by G on the moon. So that is 1 hour, square root of 9.8 meters per second squared divided by 1.63 meters per second squared. And when we plug these numbers into our calculator, we end up with 2.45 hours.